we won't be able to complete this here anyhow. All right, so we have seen this lambda optimizer. We have already seen how we can convert this thing. And okay, now in Java now this is possible, right? We don't, that the thing that we were doing in a separate class, now we can do it in a single line, right? This is the beauty of the lambdas. Also, now we have seen how to create lambdas. We have covered all the way to create a thread. Now we have, okay, we know the cycle, we know the basic things and flows. All right, so Thread.sleep also we have covered. Okay, let me just, we can start the recording now. So in the old part, there used to have three methods. One is yield method, and the one is, we have already using it, right? Join method. Okay, not this one, we are using sleep method. All right, now we can touch the synchronized keyword as well. Okay, so these are the three methods that we usually use. So we'll start from Thread.sleep that we have already seen, right? Okay, we'll start with the Thread.sleep or Thread.yield. What will happen if I use the Thread.yield? Why I yield runner? Cool. So see what will happen if I yield anything. So let me create a task. Task is to print 1 to 5, right? Counting task. All right, so I'm going to create a counting task. So in the counting task I will just start from 5 and then I++. Cool. And over here I'll just print I+1. And let's add thread name as well. Thread.get name. Counting, and this is not a string, this is this. Cool. So now I'll give a thread this task, thread counting thread, new thread and counting task, right? And counting thread is start. Cool. If I run this, the thread will count it from 1 to 5, right? And it will go in a single, and the thread 0 is doing all these things. But I want to wait as well, right? So Thread.sleep we are already using, right, for a while. Let's wait for 2 seconds and simply, all right, if we run this, oh shit, this is the drawback of the lambdas, that if you want to use sleep, then we have to provide the try catch. There is no alternative. Okay, so let's run it. Counting thread, right? 0. Now it's counting right now. But what if I want to give up? What will be the stages? Let's just remove this thing for a while. This will be the running state, right, of a thread? Yes or no?
Yes.
Because this is the implementation of run method, right, that we are overriding. So if this line is executing, then it means the thread is in running state, right? But there is a method. Thread.yield. Okay, so you will see it's a static method, right? So when I call this method, it will make sure that the when CPU, what is the condition for running, that CPU must be there, right? Processing power is required by the thread, right? I'm audible?
Yeah.
But for this, that would not be the case, right? I mean, that would be the case that if it's running, then that means CPU is provided by the thread scheduler, right? But what if my thread don't want the CPU power? I can leave the processing power. I can ask for leaving the processing power. A hint to the scheduler, right? Which scheduler? Thread scheduler. That the current thread is willing to yield its current use of processor, right? The scheduler is free to ignore the sent as well, right? It's not mandatory for the scheduler to make sure that whether he wants to take the resources from this or not. Right now, it will have no impact if we try to yield. The reason is, like in the case of garbage collector, we can just submit a request. Similarly, with the thread scheduler also, we can submit the request. Whether it want to take the processor away or not, it completely depend on the JVM implementation. That would be the vendor specific. And also, if I'll run, why the processing power will not be taken away from it? The reason being, the task will be so fast because I'm just printing from 1 to 10, right? This task will be executed so fast. Then by the time the request reaches to the scheduler, that okay, I want to yield, it will have been completed. The entire task will be completed, right? So scheduler automatically reject the request also. If another case will be, if scheduler thinks that okay, I will take the resources from this thread, then what will happen? The scheduler has to provide the resource to another thread, right? But there is only a single thread, so it will take the processor from this thread, again gives it back, again takes it and again give it back, right? So the flow will be so fast that we won't be seeing it, right? If from our naked eye, right? See, nothing happened, right? Even if something is happening, then also we won't be able to judge what happened, for how long it happened, right? Because it's happening in the milliseconds. So this is the first thing, and it's a old interview question. What happens when we yield the resource? And one thing to know, never use this thing in the production environment, because in production environment we don't know, because there will be, in the local environment we have multiple things, right? First thing, you will never get a chance to use the yield. Another thing, never use it also, because the thing is, if let's suppose you have a thread that's executing something and you use thread.yield, right? What if your thread, in our case there is a single thread, but what if in the production environment, the thread scheduler accepts your request and takes the resources from you, right? And then what will happen? After how long you are going to get the resource again? Now that would be a dilemma, right? Am I audible?
Yeah, yeah, yeah.
So we never use this thing in the environment, in the production environment. That's why people stopped asking this question as well, way long before. But it still exists, right? It's not even obsolete. If you go over here, no obsolete written, right? And deprecated, sorry. Java use the terminology deprecated. Another thing will be sleep, right? We are already using it for a long time. So now the thing is how it usually happen, right? Basic sleep. So in this lines, let's run something in the loop. Hello, right? Hello user. Now what will happen if I'll do, after printing hello user, if I do thread.sleep, right, and pass the 2 seconds. Alright, the one thing with the thread.sleep is it throws a interpret exception, and interpret exception is a compile time exception. How I know it's a compile time exception? Because it extends the exception class, right? So if whenever we are using thread.sleep, first thing is the static method like the yield, right? It's a static, so I can directly use it by the class name. Cool. So two methods, sleep and yield, sleep and yield, right? These both are static methods, right, that I can directly use with the class name. But yield does not throw any error, right? Any exception, no exception throws, right? So I can directly use it. But if I want to use my basic sleep runner, then it throws an interrupted exception, right? I'm audible, so I need to handle it whenever I'm using. So one thing is to handle it, another thing is to delegate, right? Exception handling we have already seen. So right now we are not going to handle it, right? I can write the throws here, but I prefer this thing, right? Annotation. So I'll just throw it. I'll just run this. Now our variable in, okay, my bad. Let's set 5, right? This would be the basic case, right? You can argue that okay, we haven't written any thread right over here, but the main thread is also a thread, right? This code is also executed by a thread, right? That would be the main thread. So main thread is responsible to run these lines, right? And don't believe anyone, you can directly just get this thing, right? We have already done this many times, so you already know the main thread will be visible, right? Main thread is executing these lines. So now the thing is, we need to know the sleep. One thing we know already that okay, sleep throws an interrupted exception, right? Another thing that we need to know, how many constructor is of sleep class. 1 and 2. 1 we have been using, right, directly. It takes the time in milliseconds, right? But there are one more sleep method, alright, it's overloaded. Now in the sleep method, okay, I have milliseconds and nanoseconds as well, right? Again, I don't think you are ever going to use this thing in your life. If when you want a specific 30 milliseconds and 4 nanoseconds, right? These timelines are way too oblique for a human to process, so you will never get to use in your life. But it's fine. I mean, you can use this directly, right? So there is one thing. So if you want to use, and if you will find any code written like this, right, then it will run. It just overloaded, right? So this millisecond, this nanoseconds. Cool, clear till now?
Yeah.
All right. So the next thing is, again, this is a basic of sleep method. So negative time, negative sleep time. All right, so the same thing will be there, right? Okay, so instead of doing anything, I'll just do the thread.sleep and sys out code is started at by. Alright, ended as well. If I'll pass 2 seconds over here, and if I run this, then started by this and okay, ended by the same thread after a while, right? Then is I'm not creating any thread, the main thread is already created, so it will be executing this line. But if I'll pass negative, right, I'm passing negative value, right?
Yeah.
What will happen if I'll pass negative? So the thing is, the sleep method takes an integer, right? Integer can take the negative as well, right? But if I run this, illegal argument, we cannot pass a negative, right? How can I not sleep? I mean, negative sleep will be awake, right? Yes or no?
Yeah, yeah.
And
Okay.
we were already awake, right? You were saying it was the thread was executing the lines, so it was already awake. So why how can you say that please be awake for 2 seconds, right? So this is the argument. So if you try to make sure that this takes a leave, then this is the work of the tester, right? If we know that okay, integer I can pass, okay, over here it's long, right? But why it is taking integer as well? When I'm passing the negative value, it's taking the negative value as well, right? in overloading overriding, we have seen one concept, right? Upcasting and downcasting.
Yeah, yeah.
Okay, okay,
Yes,
all
yes.
right. So the same thing will happen, right? I mean, don't get confused. And if and also, see, this is the thing. The advanced topics are not advanced. They just require the basics also. And that's the only thing. If you know the basic thing, then you will get it. All right. Not going to go again and cover that thing again. You can refer the videos and notes. All right. Moving ahead. And now another thing, right? And that would be interrupt thread runner. Okay. So we have a thread, right? Okay. So same lines we can just copy over here. I'm saying, okay, no, for this I have to write a task. So I am creating a runner and task, right? Counting task I'm creating. So simple D 544. Okay. Okay, and thread name. All right. Now it's counting I. So I can also do plus plus I, right? What it's going to do? It will add the value first, then place it, right? So the output will be 1 2 3 4 5, right? And then I'm going to use thread equals to new thread, and I'm going to pass the task. I can name this thread as counting thread as well. Counting thread and counting thread dot start, and cool. So this will be the, and if I run the code, okay, because there is no Thread.sleep, right? My bad. I want to use Thread.sleep. Okay, no worries. So let's add sleep for 2 seconds after everything. Okay, and instead of 2 seconds, let's add sleep for 10 seconds, right? 1000, yeah, it's 10 seconds. But we need to handle the try catch, right? Try catch, cool. So for single liners, we can just optimize by, can we remove these things? For single liners, we usually can remove these things, right? Try and catch, right? If for if case we have just seen it today, right?
Yeah.
But can we remove it for try catch? No, we have just seen, right? We cannot remove. Visual, there is error expected. So it's mandatory to have the curly braces for this thing. That's why I hate this, because it don't work well with lambdas. Okay, but I can, okay, we'll see it later on. There is way around, right? Don't use runnable, but we'll see in the later sessions, not now. So otherwise you can get confused. Okay, so if I run this, what will happen? The thread will wait for 10 seconds, right? Let's add one more second. Okay, we don't have 10 seconds, so let's add 2 seconds. And code started by, and over here, what will be the output of this line number 6? Which thread will execute this? Line number 6?
Main thread.
Great. And line number 22? Main, right?
Main thread only. Main
Yes. Which will execute line number 11?
thread 0.
Yes. So let's run this now. Main thread has stopped is working, right? And the thread 0 is working now. Cool. Now what I can do is simply I'll wait for, now I'm increasing its time to 5 seconds, right? And now over here let me wait for, okay, let me wait for 1 second. Thread.sleep. Which thread I'm asking to sleep? Main thread, right? In this line I'm asking main thread to sleep, right? So let me add sneaky throws here now. Cool. I'm asking main thread to stop, right? So instead of happening this, it is going to wait for, main thread is going to wait for 2 seconds. Code started, main thread is also waiting. 2 seconds over, main thread has ended, right? So it's taking 5 seconds. So what I want to do is simply after 2 seconds, I will take counting thread, right? And I will interrupt it, right? You might ask, right, when the thread is sleeping. Okay, we can have this thing, no worries. You can say that when the thread is sleeping, the thread interrupt exception is there, right? But the question must arise, right? How it will happen, right? How it will arise? Null pointer exception will arise when there is a null pointer, right? The file not found exception will find when there is a path given and there is no file there. Error index out of bound will happen when there is a index size, index length of 5 and we are trying to accessing the index of 6, right? So this is how the exception will happen, right? But what about the interrupt exception, right? We know that okay, a thread is sleeping, but and someone wakes it up, right? But who? I will wake it up, right? At line number 26, right? Now if I run this, after 2 seconds, main thread is waiting, right? Main thread waited for 2 seconds and then it interrupted the thread, right? Interrupted the thread, right? Visible? Am I audible?
Yeah.
So this is clear, right?
No, could you go over it again?
Alright, cool. See, there's a main thread executing this line, right? Now there's a counting thread. We have created a counting thread, right? So the thread 0 is executing this line, right? Thread 0 is executing line number 14, right? It has printed also line number 14. This thread name, thread 0, and it counted 1. So, and then after it will going to sleep for 5 seconds, right?
Yeah.
And main thread is waiting for 2 seconds. So after main thread had started the thread, right? Main thread will come here first. Nothing will happen, right? Main is printed here till now. Now the main thread is at line number 23. And it registered the counting thread to the thread schedule, right? And then it will come to line number 25. Now this counting thread will execute parallelly. Now the thread is waiting, main thread is waiting for 2 seconds after, and then this will be registered, the counting thread will be registered to the thread scheduler and will be provided the processing power. So that's why thread with thread name and the count is here, right? Then it will wait for 5 seconds and our thread was already waiting for 2 seconds, right? So as soon as 2 seconds gets over, the main thread will interrupt the another thread. So who will wake this thread, right? Counting thread. I'm saying that okay, counting thread, please wait for 5 seconds, right? An interrupted exception will arise when someone will wake this thread up, right? He's sleeping, right?
Okay.
This line number, this is counting thread, right? Okay, let me just change the name of this thread as well. Counting thread, right? Let's run this again. So thread name counting thread, right? Counting thread printed 1 and then counting thread was sleeping for 5 seconds, right?
Yeah.
And I asked main thread to sleep also for 2 seconds. The reason is there might be a chance that thread scheduler won't be able to provide the processing power, and at that time I will try to awake the counting thread, right? Interrupt the counting thread. So that's why I made sure that okay, my main thread is waiting for 2 seconds. So main thread was also sleeping and my counting thread was also sleeping, right? But main thread is sleeping for only 2 seconds. And as soon as my main thread wakes up, it goes and wakes up the counting thread also. That's what it's written, right? Counting thread interrupt. What
Yeah.
interrupt? It sleeps interrupt. And if someone interrupts your sleep, then interrupted exception will get thrown, right?
Yeah. Yeah. Okay.
Okay. So see, whenever we use the thread.sleep, it was mentioned in the method that okay, you need to handle thread interrupted exception, right? And what's the interrupted exception? That if someone wakes your threads up, right? And who will wake your thread? Another thread. In this case, main thread is waking. In line number this, main thread is waking up, or in another line, interrupting the counting thread, right? This is what happening, right? And as it will happen, we'll get the error, right? Cool. Clear till now?
Yeah. Got it.
Okay, this is the basics. Again, now the question usually is something else, right? This is the interview question, right? I'm not writing in the interview question part, I'm writing it directly. Cool. Okay, should I write it in the interview? Okay, let me just put it in interrupted exception cause interview package. I don't know whether you guys will come back to this and see the repo, but I should do things from my part at least. So negative and these two are interview questions, right? All right. And then the next interview question from sleep itself, right? And that would be, oh shit, interrupt. Okay, cool. Yes, interrupt while awake. Okay, runner as well. Runner, cool. So let me just copy paste the code from here. Alright, even entire code. Okay, I can copy paste entire code. Alright, the only change I'm going to do is I will remove the sleep from here, and instead of 5 I'm not okay instead of 5 okay, let's print 1 lakh times, right? Just to make sure that we have enough time for our task to start, right, before main thread ends. Sneaky throws. Or even the better thing would be 1 lakh can be completed into 1 second. Okay, so what I can do, I will, okay, let's check. Okay, and 1 second, 100 milliseconds we take. In 100 milliseconds will our thread start working? Okay, I will not interrupting first. Code started by main. End it. Okay, great. So 100 milliseconds is worth it. Cool. So what I'm going to do, so we have seen that, okay, let me run it again. We have seen that I can count, I'm waiting for 100 milliseconds, right? And before 100 milliseconds get completed, my thread is able to cover its task, right? It able to print. Okay, 999. Let's add 20 milliseconds more. 999 only, right? Then okay, I less than 1000. Cool. So it should start from less than 1000, starting from 0. Okay, so that should be 1000. Why it's 999 only? The one thing should be first. Okay, I'm adding twice. Cool. I can ignore this thing. Alright, now the counting would be fine, right? Okay, let's rerun again. Now it's 1000, right? Cool. So where were we? All right, so now we know that okay, 120 milliseconds, even the 100 milliseconds is enough for our counting thread task to complete its task, right? Visible? Because code ended by main, right?
Yeah.
Clear? Cool. So if I try to interrupt it, right, what will happen? Main thread, the same thing is going on, right? What will happen now? See, is the main thread sleeping? When will the error happen? When the thread is sleeping and someone comes and wakes them up, right?
Yeah.
But what if you are already awake? If you are awake and someone comes and say, okay, hey, please be awake, what will you say? Chal kaam kar
Uh,
apna, right? So that's the thing, right? So same goes with this also, right? So if I run this, nothing will happen. The counting thread will say chal kaam kar apna to the main thread, and that's what you will see inside this also, unless the current thread is interrupting itself. Okay, that's that's a great thing, which is always permitted. Okay, okay. Ting 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 ting. Okay. If the thread is blocked, then the interrupt status will be set immediately. If none of the precondition holds, thread status will be set. Interrupting a thread that is not alive. Okay, that is our second interview question. Okay, awake. Okay, okay. They have changed their documentation a little bit. Okay, the final part. All right, interrupt. We'll okay, okay. Now this documentation seems little different. Okay, this is blocked IO. There is nothing written for the awake ones. Okay, wake up. No. All right, cool. No worries. If a thread is awake, it's not written. They have just mentioned that okay, if those conditions not met, then nothing will happen, right? So one of the condition that if not met is if the thread is already awake, then the interrupt will have no impact. Cool. That would be the first thing. So nothing will happen in this case, right? Over here, nothing will happen as thread is already awake. Cool. That would be the one thing. So that would the interview question, interrupt while awake. Another would be interrupt while dead. Same code I'm going to copy paste. Alright. Now the thing is, okay. Actually, last time we have covered interrupt while dead, because the task was already completed, right? And then the main thread executed, right? I'm audible?
yeah.
So this the example that we have taken, because the thing is when the line comes here, our thread was already completed a task, right? Over here when this for loop gets completed, that means thread will be dead, right? Over here the state will be dead state, right? If it crosses this line, it's a for loop. When it's end, the thread will be dead. And if a thread is dead, how can you wake up someone who is already dead, right? So nothing will happen. So this is as thread is dead. This will be the case of thread is dead when we are using 120 this thing, right? And while awake we require less time, right? Let's take 10 milliseconds and don't interrupt first and then check. Cool, right? In 10 milliseconds it's not able to complete the task, right? So the main thread, okay, let's search this code ended by right, it's on 196 and the main thread start execution, right? Main thread gets completed. Cool. So this line will be the example of we are trying to awake the thread while it's working or already awake. See, nothing happened, right? No error. The reason is because the thread was already awake, and the example that we have done was the example when the thread is already dead. So the thing is, we cannot wake who is to someone who is already dead, and we cannot even awake someone who is already awake, right?
Yeah.
Okay, so that's with the thread.sleep method as well, sorry, interrupt method as well. Cool. And the final thing is, if I'll try to interrupt myself. What if I'm trying to interrupt myself, right? Interrupt yourself. I don't know. Right? So, okay, my bad. So don't need to create another thread. So who is this thread? Okay, let's get the thread, main thread, main thread equals to new, not new, thread dot current thread, right? This will be the main thread, right? Fit thread with name, main thread, right? This thing will happen, right? Sys out code ended by main thread get name, right? Code started by. Okay, and get name. Cool. So if we run this, we'll get code started by main thread and ended by main thread, right? So I have a main thread with myself, right? And interrupt also. So who will be okay? Let's go back. Who was interrupting the counting thread? Who was interrupting the counting thread over here?
Main thread.
Yes. And okay, and where is self? Where is self? Here. Okay, cool. So who is interrupting main thread over here?
Main thread itself.
Yes. So main thread is awake, right? Over here. That's why he's awaking himself, right? He's trying to make himself awake, right? So what will happen in this case? Nothing happened, right? Right or no?
Yeah. Yeah. Yes.
Yeah.
See this thing, right? So these are just question to make someone get confused, right? So, but we don't have to. It's simple, right? If someone is dead, we cannot wake them up, right? It will be a miracle. And if someone is already awake, he will abuse you, right? And say, and okay, cool. And again, you cannot wake yourself up, right? You will wake up, but you cannot interrupt your sleep, right? So it's not like you can slap yourself while you are sleeping just to make sure you are awake. So again, this call will be wasted as well because the main thread is already awake, right? Cool. You can run this on your own and you can check it. And the thing is, if I'm sleeping, right, then what will happen? I can pass the main thread object to some other method and I can run it in the child method, and then the other thread will interrupt the main thread. Then it will work. Self interruption is not allowed. Cool. It's just simply like with the humans, but what happens? It's the same thing that happens with the thread as well. All right, let's move to the join method, the third method of the old quotient thing. Okay, and the alternative of the join is latches in the new cases. So for the join method, okay, join method, okay, cool. Now we can have a okay, now we can start working with the threads, main properly with the threads, right? So see, okay, all right, cool, great. So what I'm going to do, there is a marriage, right? Marriage handler. Okay, we do the runner. Okay, marriage handler runner. Cool. So how are you going to get married? Let's suppose there is a how people marry, right? They search each other in the matrimony site, right? Bride, groom, searching on morning, right? Cool. Then the next thing is they will meet, right? Bride and groom meet, and then bride groom accepted each other. I think I'm okay. The characters are same, the actors are same. Okay, so let's remove one line, more line, right? And even remove this line also, right? We don't have to start from the very basics. We want it independent characters. So parents meet, bride groom, parents meet, right? Then astrologer find a spacious date, right? I think spelling is wrong. Okay, okay, let's just check. Okay, all right. Anyone knows? Okay, cool, let's leave. If someone knows, then please let me know what's the correct spelling of this. And then what happen? Astrologer meets, and then okay, then uncle. Okay, then groom. Okay, the uncle will क्या करेंगे? Okay, okay, banquet hall, book banquet hall, book banquet hall. Uncle booked, not will. Uncle booked. Okay, and when uncle booked the banquet hall and astrologer find auspicious date, for that date uncle will book the hall, and then the brother will print the cards, right? And then the parents will invite the guest, and then finally marriage successfully completes, right? Cool, this is how things happen, right? I'm audible?
Yeah.
Okay, see, if you run this, then this is how things will happen, right? But the thing is, usually it's not happen like this, right? Usually sometimes will take, right? Okay, wait, my bad. Usually bride and groom will meet, but they can take some seconds, right? They will take some time. Let's take that. Okay, they will decide in 2 days, so we'll take 2 seconds, right? Then the parents will meet, right? Then parents will meet, and then okay, they will decide something, right? Let's say they decide whether they will allow their kids or not. Let's say they will take 4 seconds, right? 4 days. They will do the comedy things and all of those other things, right? Whatever in their religion it is. Then astrologer will come, he will take less time, right? Astrologer will take some hours, so let's say that 1 second is taken by the astrologer to set things up, to find the auspicious date and find and match the only and all those things. Then let's say someone, let's not, I mean, I have mentioned that these things will happen. Let's say that all these things is done by only a single person, right? Not uncle, brother, right? Let's suppose the groom is already doing all those things, right? Okay, let groom book this thing, then groom this thing, then groom is already going for doing this thing, right? So to book the banquet hall, it took him 2 days to find and book it, right? Then to print card, to find the guy who can print, let's say it took him 1.5 day. And then to invite the guest, let's suppose he is inviting 2000 or not 2000, 200 people. So let's suppose it's going to take 4 days for him to invite all those people, right? And the marriage is going to complete in a single day. Cool. So now if I run this thing, right? So everything is going to take some time, right? It's not like in a GIF it will happen, right? But do we have what we'll do in the real life, right? Bridegroom we cannot replace with any other person, right? They have to go themselves to meet each other, right? So this is not an independent task, but it is dependent also. Which tasks are dependent? Bridegroom's parent meet, right? This is independent task, right? because parents are meeting, not the children's. So this is independent task. Astrologer will come. This is again an independent task. The astrologer can find any date, right? Then this thing, banquet hall, book banquet hall, right? This is independent task. Anyone can come, anyone can do it. For these three tasks, at least the same character needs to be present there, right? Sorry, yes, these three, right? For these three tasks, same person needs to be there, right? Bride and groom are the same characters, or the actors, we call it in the coding padding. Or in the bridegroom also, the parents are also the same actors. Astrologer is the actor, can be any actor, but it's an actor. But these tasks are independent, right? Whether groom will go to book the banquet hall, whether the uncle will go, right? This will happen, right? No one will let the groom do all the tasks. The tasks will be separated. Groom's brother will go, groom's sister will go, groom's uncle will go, parental uncle, maternal uncle, nobody cares. Well, someone else will take care of those things, right? Am I audible?
Yeah.
Yeah.
Okay, see, cool, great. So what we can do, we know that okay, these tasks will be provided, and it's taking a lot of time, right? This thing was taking a lot of time. So what we can do, we can give this task to some other people. We are not letting the groom doing all the tasks, right? So let's suppose this was a task. So okay, so now we know how to create the task is also, right? So what I'm going to do over here is simply, so thread bridegroom meet task, right? This was a task, right, which need to be completed, right? So I have created a single this thing, right? Visible?
Yeah.
And okay, let's keep this task there, right? Now I don't need Thread.sleep, right? Again, this thing I'm going to do again with the thread. Parents meet task, right? And okay, cool. Now this is a parents meet task. And similarly, okay, I have to do a lot of things again. So okay, cool, no worries, I have to write it. Okay, thread, which task is there? Astrologer, right? Astrologer task. Banquet hall book. Okay, now it's, which task is this? Okay, card print task. Thread card print task, new thread. Okay, and now with our list, inviting guest guest task. Okay, now finally the final task of marriage. Cool. So now we have multiple threads, right? My bad. Okay, visible? Multiple tasks we have right now, right?
Yeah.
I'll be inviting. Okay, cool. So we can start, right? Bridegroom meet task, start. Cool. Parent meet task, start. Astrologer task, start. Banquet hall task, start. card print task, I start inviting guest task, start marriage task, I start, right? Cool, fine. 1 2 3 4 5 6 7 tasks we have created and 7 tasks we have started, right? If we run this now, see, bridegroom meet, bridegroom parents meet, auspicious date is fine, banquet hall booked, print card, inviting guest, and complete successfully, right? Visible? And everything is done by different thread, right?
Yeah.
And if we do this, we think that we have conquered the multi-threading, but we are at the very initial stage. We are at the complete beginner right now. See, if I have run this again, right, still it's fine, right? I will run it multiple times. See what happened now when I run it third time, because what happened when I submit a task, it goes to the thread scheduler, right? And now thread scheduler will give the processing power. It will not execute in sequence just because you have written it in a sequence, right? And you can see it over here when I run it in the third time, bride group meets, right? Then without the parents approval, astrologer is finding the date. Visible? And banquet hall is booked and then print card gets invited. The other sequence is correct, but here the sequence has been altered, right? This sequence, right? Visible?
Yeah.
And
Yeah.
if I run it or multiple times more, then there is chance that more anomaly will see. See, we have invited the guest, right? And after inviting the guest, we are printing the cards. How you are inviting the guest when you don't have the card, right? Sequence has been disturbed, right? Sometimes
Yes.
if we run it many times, like we do in the in the production environment, there will be I have just run it 7 to 8 times, right? Completely, and we have seen multiple times, at least twice, that the sequence was not in the order that it should have been. But in the production environment, if we have daily active users of 4 5 6 lakhs, which is very common nowadays because everyone is online in India, so a single user will hit your API at least once, so 4 lakh trials in a day. So your sequence will will be altered, right? And nothing will go normally. So that should not be a case in the production environment, right? Sometimes you will see that marriage will happen first and then the bridegroom is meeting. That cannot happen, right? So those kind of scenarios will happen if you are a beginner. That's why nobody lets a fresher or even the people who are new to write code in the multi-threading. So how can we fix this thing? So now we need to find, we first thing for the multi-threading is we need to make sure we need to find the tasks which are independent and can be run by a different task, right? Parallelly we can execute, right? So we have found the task, but some tasks needs to be executed in a sequence, right? My uncle cannot directly go, okay, now I can change it, right? Groom will not go, uncle will go, and groom's brother will go, right? So brother will go to book the banquet hall and the parents will invite, right? Parents will invite, but the sequence needs to be here, right? I don't want my other task to start before the bridegroom meets, right? It don't make sense, right? Hello, I'm audible? So is there any way in which I can make sure that my other tasks don't get
Yeah.
executed until my one task gets
But
completed?
will assigning the priority. Uh,
Okay, again, see, the priority again will go to the thread schedule, right? And how is the internal implementation of thread scheduler? That will depend. Let's suppose you have made the bridegroom priority 10 and parents start priority, parents meet priority 1, right? But I have 4 cores in my system, right? At least every system has more cores, right? Okay, I think my system will have at least 3 to 4 cores minimum, or hexa core. 8 GB. Okay, not coverage. I mean, at least octa core or hexa core I'm expecting, right? Not octa, to at least hexa core it will be. My system will be, right? So every system has, even the phones has multiple cores right now, right? Into this setup. So if even if I know I'm not at a very high level right now, right? But even if I can think that if I have 4 cores and I have 4 tasks, right, I can give each task to a core, right, regardless of their priority. If I am a thread scheduler writer, right? I'm audible?
Yeah.
Even if your priority is low, but I have more cores to process, I will give it to other processors, right? And also you cannot predict the algorithm in which the thread scheduler is written, and it will keep on changing when you upgrade your Java version, or you will move from your JVM vendor. From Oracle you might want to use AWS Corito, then implementation will change, right? So we cannot depend ever on the thread priorities. In the production environment we'll never play with the thread priorities. It's just there, that's it. We don't play with it. We play with it in case internally we use it, and that too we don't have to directly able to say it. We use the priority queues, right, where the priority is required in real life production, right? Okay, I'm not going to dive deep into this again, but just to just to let you know where it's usually used is, you have messages, right, A, B and C, right? You have these messages. Now you are a WhatsApp, right? You are a WhatsApp person and you want to make sure that you are sending some message. Which message should go first, right? What do you want? You want your double tick annotation, double tick message to be delivered you first, or you want another message from the user first? You send someone something, you send some message to a person like hi, right? What do you want? Double tick first, or you want his reply hi back?
Double tick first.
Yes, so double tick will have more priority, right?
Yeah.
So in those cases you can use it, but usually it not happen in this manner. We have multiple queues, and in queues we have priorities. So there are different separate queue for the double tick. So that's why sometimes somewhere you have seen that you get the message without a double tick, right? For a few seconds only you will see it, if they have the load in their servers, because they have more queues for the double tick than for the message. And the double tick feature is less also, right? You just need to send acknowledgement, that's it. No extra data is passing through, no security you require, right, for this. So it's usually easy also to do it. So the internal implementation is different, but at these cases you can do the priorities, right? Cool, but we are not going to do the priority task, right? Because there might be there might be a chance, right? Different cores will execute other task. So here I have a thing. My main thread is starting registering all the tasks, right? Once it gets registered, then I have no control. I have the control before the registration of those threads, right? So what I can do, there is a method called join, right? We are inside a join. So it says, and the join method, the rest two methods are static method, right? Sleep and yield. But join method is instance method, right? So it will run on object. So now I have used the bright meet task dot join. What does it mean? The current thread who is executing the line number 20, right? The current thread will wait until the thread on which join is used gets completed. Cool. So now until unless, who is executing this line? Main thread, right? And main thread is responsible to register the parent or other tasks as well, right? Am I audible?
Yeah.
So now the main thread will wait until my bridegroom task will end, right? Till the bridegroom task is not completed, till the thread is not completed this task, it will not move in line number 23, right? Because it's registering the other threads, right? And same thing I want to do with the parent task as well, right? Until the parents agree, I don't want other pundit to get the date, right? And also until the pundit has decided a date, or astrologer has decided a date, I don't want to book the banquet hall, right? Because it makes no sense. You need a date to book a banquet hall, right, for the marriage. And same thing goes with the card. For a card you need the banquet hall and you need a date, right? So I need to wait, right, for astrologer, right? And for banquet hall as well, when the astrologer agrees, then I can go and ask for the banquet hall, right? And until the banquet hall is booked, I need to wait for print the card, right? And until the card printing is done, I need to wait for inviting the guest, right? And until I have invited the guest, I should not start the marriage, right? Marriage is done, then I cannot invite other people, right, for the marriage. Cool. But every task says, we have written every task in such a manner that no two tasks we are executing simultaneously, right? So when the bride has agreed and parents agreed, astrologer found the date. Now after this thing, right, after the date has there, we can add one more task, right? Bride, groom, buying clothes task, right? New thread. Bride, groom, buying clothes for marriage, right? Now you can say why after the astrologer find the date, right? The reason is, if the astrologer finds the date for the July, then you will buy the clothes for the summer. If they find the date for the December, then you'll buy the date for the winters, right? So you need the date before you start buying things. And bridegroom buy trade, and I can put it after astrologer task gets completed, then I can just start the task here, right? So these two tasks can run simultaneously, right? I'm audible?
Yeah.
See, bridegroom is going to buy the clothes, and brother is booking the banquet hall, right? These two tasks are non-independent and non-linked as well. Other tasks are linked. That okay, if the bridegroom agrees, then only parents can meet, right? If they reject each other, the parents will not meet, right? It's not. So these two tasks are dependent. If both parents agreed, then the astrologer will come, right? So astrologers finding the date, auspicious date, is dependent on these two tasks. But once the astrologer has found a date, then buying clothes and booking the banquet hall, these two tasks are independent, right? But again, for printing the cards, we want the date and we also want the banquet hall details, right? That's what we are going to print in the card. So that's again a independent task, but it's dependent on other tasks as well. So it can be done by someone else, some other actor, but it needs detail from the previous actor. From Pandit or the astrologer, it requires the date. So this is how we have written the code. Now, if regardless of how many times are in the code, we are going, okay, where? Okay, my bad. Cool. Now, regardless how many times I run the code, the sequence will never get changed. Illegal, okay, illegal monitor state, where? Okay, my bad. Restart. Astrologer task, join we need to use, not wait, join. Cool. So we can run it again. Okay. See. Bridegroom meet, bridegroom parents meet, astrologer find the date, bridegroom buying clothes, right? The brother book the banquet hall, uncle print cards, parent invite the guest, might happen successfully, right? So now I have done these things, right? Just try to focus on these two lines, right? Bridegroom buying clothes and the brother booking the banquet hall. These two things can change the sequence. Other than this, nothing else is going to change the sequence now. So these two are buying clothes first. Still buying clothes first. Still buying clothes first. Okay. There is still buying clothes first. Cool. All right. Okay, it's not happening, but if we run it multiple times, somewhere down the road it will happen. So this is it, and usually the thing is it's way too close. These two lines are way too close. So by the time this will register, and by the time this line will get registered and the thread scheduler will provide the task, it's already been executed, right? Because the task is way too slow, way too less for consuming time, right? A single line we have to print without any sleep. That's why this is happening. But by using the join, we are making sure that our dependent tasks which is executed by different threads are happening in sequence, right? Am I audible?
Yeah.
Yeah.
So is this in clear? So what's the
Yeah.
drawback of this? See, join method no one is using right now, right? And okay, join is all overloaded as well, right? Join is overloaded as well. So you can see you can send the millisecond as well, right? Why the milliseconds? You can wait for, if you want a task, right? This task, the example that we have taken, right? The bridegroom needs to marry, right? So that task will be dependent, indefinitely dependent, right? We have to wait for unlimited time. If bridegroom is taking 1 month, right, to meet, or 1 year to meet, right, we all the other peoples need to wait, right? It's non-negotiable. But there can be some other tasks where you just want to wait for a few seconds, right? If your order is coming within a half hour, then you will eat a food in a restaurant, otherwise you will leave, right? And you will go to some other restaurant, right? This is the way things works, right, in the real world. I'm audible?
Yeah.
If you go to a restaurant and they are not serving you within 4 hours, you will leave, right? So that's the thing we can do over here. We can mention the timing as well, like just wait for 2 seconds, right? After 2 seconds, the main thread, what's written, wait, current thread will wait until the thread on which it is used gets completed, right? So bridegroom task, it's not going to wait for it to get completed, right? It will wait for maximum 2 seconds. Let's suppose this is going to get completed within a second, then it's completely fine. If it's completed within a second, then okay, cool, it will move ahead. But maximum it will wait 2 seconds. After 2 seconds, let's, for example, it needs 10 seconds to get completed, but the code will not wait, the main thread will not wait. Current thread is the main thread, right? So the main thread will not wait for the 10 second maximum. I have mentioned that okay, please wait for 2 second max, then move ahead. This is it, the meaning of overloaded method. Cool, understood? Just like the sleep, but over here we are mentioning the time. Just wait for 2 seconds and that's it, and then move ahead. If the bridegroom task is not completed, move ahead, right? Make sure the parents meet. There might be a chance that parent might be able to decide. So that's the thing of join method being overloaded. Cool. So what's the drawback of this? Drawback is this is a instance method, right? I need to, if I want to make sure that when this task gets completed, then only I'll move forward, right? For this thing, I need to pass my thread object, right? This is a thread object, right, on which I have used the join method. Join method is an instance method of the thread class, right? So if in the case, the same example, let's say the same example, if I want some other class, right? If I want some other class to handle this thing, right, to on off, then I need to pass 7 threads, right? So let's suppose I have a more complicated task which requires 50 threads. Will I be just sending the n number of threads, keep on passing the n number of threads, right? This does not make sense, right? Because if my method is expecting some threads, I have to check for the null pointer also. Null pointer is also a drawback of Java, but we have to deal with it, right? Because it is present even in today's age also. So null pointer I have to check for the 50 data, right? It does not make sense. Over here it's completely fine. I know that okay, it's not null, but if I'm expecting some method is expecting, then the null checks will be there also. So it is not feasible to handle a task where is multiple dependency of multiple threads is there. This thing is not feasible. So nobody used join after Java 9. Sorry, not 9. After Java 5, which was introduced in 2009. So this thing is obsolete. But some people might ask you this question: what is join? So by join, what happens? The current thread will wait for the thread on which the join method is called, right? The current thread who is executing the line will not move forward. If the join method is overloaded with the time limit, then for that particular time only it will wait. If the thread on which the join has been called completes before the maximum time, then it will move forward as normally. Otherwise it will move ahead after the time limit gets crossed. Cool? Clear till now?
Yeah.
Yeah.
All right. So okay, now what we can do, we can, should we start the synchronized? Okay. Do everyone has a bandwidth for one more hour? So this is the most one of the most important items, right, which we will going to start. Button setting synchronized. Am I audible?
Yeah, yeah, should be audible.
It is possible to create a job. Okay, I don't want to create a class by this, so we can stay connected for till 9:30, right?
It will be more time.
Come again.
Yeah, I think
Okay, cool.
up to 9 is it is okay for me.
Up to 9. Just give me 1 second. Let me just check which. Let me just write down which things needs to covered at least. Okay, till 9. Okay, shared class level, object level. All right. Okay. Oh, let me stop the recording.